Hello, this is Team Horus for the Better Health Hackathon conducted by HCL. In this demo video, we'll walk you through our solution. Let's first take a quick look at the problem statement. We chose the first problem statement, prevention and containment, which asked for ideas to help people better cope with the challenges of self-isolation impacting their physical and mental well-being. We also took into the suggestion better self-care and mental health solutions to reduce social isolation, depression, and cabin fever. To more on how we came to the solution and what our study was, links for presentation and project pages can be found below. Let's move on to what our solution can actually provide to the user. After a small introductory page, the user is asked to log in. The login credentials are required in order to personalize the solution for the user. So once they log in, we record a speech sample. We request the user to say a sentence, "Today was a good day," while they record themselves. They can start the audio recording. As you can see here, the microphone will be recording here. They can stop the recording and they will then analyze this particular voice sample. So once they press analyze, our ML models at the backend analyze the audio and give us a score, which we will be giving it back to the user. Not just the score, but we will also be giving suggestions on how they can lessen the score, as less the score, better the mental health. So we also give a graphical representation of what their health has been for the past few days if the user has given us audio samples for the past few days as well. So for a moderately healthy person, we suggest for soft music or an audio guide by a doctor for about different health, or phone a friend. The user can also log out. Now, this is just a front end or a front user perspective view. What happens with the model? What happens at the back end? We use a random forest regressor model at the back end, which is trained and tested on a 3:1 data set. So once the audio file is given to us from the front end, the model analyzes this particular audio, gets a view of the acoustic features, and does its prediction. Now, what are the acoustic features? So we take three main acoustic features of an audio file with the help of Librosa, a library in Python. So the first acoustic feature is the Mel frequency septum coefficient, or MFCC, which helps us identify phonemes and speech signals in the audio file. We found from our study that 13 of the first few coefficients in an array of a large number of coefficients, the first 13 is important and it gives us more accuracy, so we have used the first 13. The next feature is the zero crossing rate. Now, zero crossing rate helps us extract the voiced speech. A large zero crossing rate means that there is no dominant unvoiced speech or low frequency oscillation. The third feature is the chroma feature or chromogram, which helps us in identifying pitches, the different pitches in the audio file. There are 12 different pitch classes, and chroma helps us in identifying all 12 of them. So we use these data in a way that can help us predict what kind of a audio sample or what kind of signs are present in this audio sample. So we then use that model to predict whether this particular audio sample has any signs of depression or not. We tested the model with a case positive sample and a case negative sample, and we got respective results. This concludes the demo. We aim to finish this project to its full functionality and further train our data in real world and outside our team. We hope this solution also brings in light to mental health, provides more ideas to general public on how to take care of their psyche. Thank you.